Okay, so all right, so here's where we left off. So we're looking at practice. All right, here's where we left off. Okay, here's where we left off. Okay, here's where we left off. So we're on going from moles to moles of atoms. All right, so here we can do the same thing as before, going from moles to moles, but we don't need Avogadro's number. We don't need anything from over here, because when we go from moles of nitrogen atoms, I'm sorry, moles of the entire compound to moles of a single atom in that compound, all we need to know is how the structure is made up. So in dinitrogen monoxide, there's 2 nitrogens and 1 oxygen. All right. So we can start here with our given quantity, 4.91 moles of N2O. And we want to know how many moles of just nitrogen atoms there are. So we're going to put moles of the entire compound on bottom so that way they cancel. And then we can put atoms of just nitrogen on top. So there's 2 nitrogen atoms in every one compound. Okay? And so then that's just a matter of multiplying 4.91 times 2, and you get 9.82 moles of nitrogen atoms. All right, so that's A. We can do the same thing for B. I'm going to put it in red here. So B wants to know how many moles of the entire compound are present if we have a sample that has 5.34 moles of just nitrogen atoms. So same concept as A, but now we're starting with just the atoms. So we have 5.37 moles of just nitrogen atoms. And so we're working with the same compound here, but now we want nitrogen atoms on bottom. So there's 2 nitrogen atoms in every 1 mole of the entire compound. And so then we will now, to plug and chug into our calculator, we would do 5.37 divided by 2, which gives us 2.69 moles of the entire compound. All right. So that wraps up that section, and we move on to dig into the periodic table a little bit more. So I had introduced the periodic table a little bit, but we're going to look more at trends and how the periodic table is set up. So here we have the periodic table. We talked about how it's arranged by atomic number. So here we go, 1, 2, 3, 4, 5, 6, 7, right? And that's the number of protons in the atom, also called the atomic number. All right. You also will notice that the weight tends to increase. So here's its weight, tends to increase as we increase that atomic number. So the periodic table is this awesome document that there's so many things going on. It's kind of quite amazing that it's such a comprehensive little table here. So we have arrangement by atomic number and weight. Those seem to increase as we increase along the periodic table. But we also have different properties too. So here in the yellow, we have metals. In the green, we have nonmetals. And in the pink here, we have transition metals. Or I'm not, sorry, not transition metals, metalloids. All right, so metals tend to take on the property of being hard and shiny. They're good conductors of heat. Conduction, they conduct heat, electricity. They typically are, I always think of like properties of like a pan. They're good conductors of heat because we can boil water. They're conductors of electricity, right? You don't want to be out in a thunderstorm with something metal on you. They're typically hard and shiny. Where nonmetals take on the opposite properties, they're typically malleable, meaning we can contort them into different objects. They are typically poor conductors of heat and electricity. Yeah, basically the opposite. And then metalloids fall in the middle. Okay. So metals are left on the periodic table and nonmetals are right, with the exception here of hydrogen. Hydrogen falls over here on the left, but really is a nonmetal. So there's some other trends on the periodic table. We have atomic size. All right. So atomic size increases as we go down, but increases as we go to the left. All right. So the largest atom on the periodic table, or the largest element, is francium, where the smallest is helium. So on the exam and on your OWL, sometimes you're given a set of elements and you have to rank them from like smallest to largest, or you have to pick out the smallest or you pick out the largest. So let's do that quickly here. So let's say beryllium, potassium, sulfur, oxygen. All right, so let's list them in smallest to largest. So we have oxygen here, sulfur, beryllium, and potassium. So the smallest is going to be the one that's closest to this top corner. So that's going to be oxygen. And then only slightly larger is going to be sulfur. And then we come over here, beryllium would be the next. Now we're looking at closest the largest is going to be closest to this francium. So beryllium is going to be second largest and potassium is going to be the largest. So if I were, ranking if I were to list them, that's how I would list them. If maybe the question asked what's the smallest, I would say oxygen. If the question asked what's the largest, I would say potassium. So another trend we have is ionization energy, and it is the complete opposite of atomic size. It increases as we go up and to the right, and it excludes the noble gases. The noble gases are those that are in this last category. So the I'm sorry, it does not exclude the noble gases. That's a different trend. All right, so the element with the highest ionization energy here is helium, and francium then has the smallest ionization energy. So again, if we were to rank them, elements, if you were to be given a list, you could do that. All right, another trend is the amount of valence electrons. All right, so the amount of valence electrons is the electrons in the outer shell of the element. All right, so this one is great. This trend corresponds a little bit with the groups. So there's 1, 2, we're going to skip a few, skip these, 3, 4, 5, 6, 7, 8. So anything in this category is going to have 1 valence electron. So cesium, if you were to be asked how many valence electrons does cesium have, it has 1. Same thing here, magnesium would have 2. We are unable to predict, these are the transition metals, and we're unable to predict their valence electrons, so that's why we skip those. Boron has 3, carbon and anything in this category, lead down here would have 4, and so on and so forth. All right, so we already went over this slide in class, but if you're watching this today on Sunday the 1st, right, tonight you have your knowledge check due. You need to respond to 2 discussion posts, and then you have your labs for 1 and 2 due. It's suggested that you keep up on those OWL homeworks. It's not technically due, but it's going to be very helpful to stay up top. And then on your last slide here, this is going to be helpful when you're going to study for the exam. You have all of the exact topics that are on the midterm.